Hello, welcome to Canetia Analytics, an AI-based, IoT-enabled structural analysis system. It's automated, so it's safe, it's online, and it's available all the time. Let's look at the problem space we're trying to address. The Camp Fire in 2018 in California was the most expensive disaster in the world in terms of insured losses. Yet it was caused by the failure of only a single power pole. 18,804 buildings were destroyed, with 52,000 evacuated and another 85 persons unfortunately losing their lives. PG&E settled for $13.5 billion, yet this took a Chapter 11 bankruptcy to get there. Additionally, the Surfside collapse in Miami in 2021 was also a huge disaster, resulting in 98 people dying, and it was due to the failure of significant structural components. Insurers there settled for over $1 billion. So, it's clear that critical structural failures can cause hundreds of casualties and billions in damage each year. And yet there are hundreds of thousands of structurally deficient buildings in the US alone. Property owners face massive liabilities with little or no ability to predict or detect unsound conditions. And the backlog of maintenance is of the order of several $1 trillion. In terms of highways, there are over 56,000 structurally deficient bridges in the US alone, according to data from the Federal Highway Administration. Asset owners have no reliable way of continually assessing structural risk. So risks are systemically underestimated, leaving the public and insurers a huge tab. Inspections are costly, often ineffective, because issues are hidden from view. That leads to economics being misjudged. Also, there's a shortage of qualified inspectors and surveyors for buildings. All of this results in a huge backlog and an inability to handle or analyze data properly, and all of that leads to inaction. Enter Canetia's solution. Our concept is mass-scale asset monitoring based on continuous 24/7 collection of naturally occurring vibrations that occur in any structure or building. Our technique leverages AI or ML to monitor assets automatically, continuously, and remotely. This means the burden on experts is considerably reduced, reducing costs in turn. Our solution is original. It's patent pending in the US at the USPTO and overseas in Canada and the EU patent offices. The benefits is that our solution reduces risk and lowers the cost of ownership by reducing insurance cost and making interventions timely. And not only that, the pandemic has hastened urgency for digital transformation, with a government emphasis on infrastructure development and repair, and demand for insurtech to innovate how risk is assessed and priced has pushed our solution to the forefront. The Canetia solution is a bit like thinking about a flaw in a bell. When a bell or any other object like a glass has a flaw, it sounds totally different to one without a flaw. And buildings, bridges, and other structures are no different, they're just more complex. Early failure detection in a Canetia solution depends on collecting enough data for a baseline, against which AI recognizes patterns in the data over time, and this allows us a predictive capacity. There are three ways of picking out things that look odd in the data. First of all, there's a flag, the probability of a frame dissimilarity to a previous one, a trend in data, or an anomaly itself. We'd like to go into that in more detail later. Here's a wireframe of our process. First of all, one of our IoT devices is fixed securely at our client's premises. This takes about the same level of skill as fitting a domestic Wi-Fi router at home. No special tools or equipment are needed. Our IoT device can be powered from a wide variety of power sources, including solar, power over Ethernet, or just a standard 120-volt outlet. Data capture begins immediately, building up a baseline over about 6 to 8 weeks. and data is sent daily via a 4G or 5G or other WAN interface to the cloud, where our neural network algorithm is hosted. And this is where the magic happens 24/7, 365 days a year. Neural network training is undertaken using unlabeled data. And when there's enough data and the model is trained, monitoring can begin. From that process, a dashboard presents a simple interface to the user. This contains site-specific data and other standing data presented about the health of the devices and other parameters. And we see here a simple traffic light visualization highlighted on the dashboard. Frames of our dashboard. This shows the geographical, standing and health data in greater detail concerned with each site. This provides essential asset management data to users, and they can check the main parameters at a glance if needed. When a user zooms in on a site, greater detail is revealed, as per the diagram on the right. Of course, users don't have to do any of this themselves. Only when anomalous data is detected is intervention likely to be required. Usually, a site visit is recommended, which can be scheduled according to the type of alarm. When this is needed, an alert may be sent to a user's smartphone via an app. The need for intervention can be muted until the beginning of the next working day. Early intervention is critical. From our earlier discussion about the campfire in 2018 in California, we're able to analyze the rate of return on investment our solution provides due to early intervention. We're able to use publicly available source data to calculate the probabilities of human errors and utility pole failures. And the main points are listed here on this slide, and they include the number of high-risk poles missed every single year, which gives us a 3% probability of an undetected high-risk failure every single year. At our price point of $150 per pole per year, the total monitoring costs enable a return on investment to be calculated. For Canetia's solution, this is more than 25 times. It is currently operating a trial of its remote monitoring technology for the LA Metro. This customer has identified the following principal objectives: the ability to detect faults early and recommend prompt intervention if required, to enable manual inspections to be efficiently scheduled and prioritized, to provide a means of optimizing repairs and inspection using actual status and data, and providing a means of signaling when an intervention is actually required. And overall, these objectives and the price point have been fully validated by this customer. This is our business model. We provide our service in return for a fixed monthly fee. It is similar to a SaaS model, but in our case, it's the survey which is provided for a service. Customer interaction begins at part 1. Here, our customer purchases the IoT device for a fixed capital charge. Full installation instructions and support are provided. The user fits the device themselves, but for larger customers, Canetia can also provide the service for them. This would be the case for our beachhead markets we discussed earlier. In part 2, our customers access the data, dashboard and ongoing support for a $200 monthly fee for every 3,000 square feet of floor or deck area. Data arising is kept in the cloud for long-term storage, and this encourages customer stickiness. In part 3, our customers will be able to access advanced analytics, detailed technical support, and other services for an additional monthly fee. We introduce some of these in the next slides. Overall, our model supports a far larger number of assets than are currently being monitored because of our much lower price point. Canetia's solution offers a 20-fold reduction in unit cost compared to other solutions. And these are the key service levels used in Tier 3. Bronze, silver, gold, and platinum levels are identified. Everybody gets 24/7 live continuous monitoring using AI. But as we progress up the value chain, different services become available, including histogram visualization and live changes in data, the traffic light warning and asset dashboard. The probability of identifying failure modes and predictive prioritization is also key to some customers. And yet further still, dedicated expert center of expertise regarding supervision and advanced asset insights would become available. It's also possible to integrate Canetia's solution with an ISO 55000 compliant asset management system, and this lends itself very well to digital twins, environmental monitoring, and other services. At the top end, we can also provide detailed finite element analysis and enterprise resource planning data integration to find out what important factors in the environment are significant for the customer in question. We can also provide asset recovery assistance and active maintenance scheduling on demand. We present a timeline and roadmap for solution development. We will have comprehensive results from the LA Metro trial by Q1 of 2023, with verification and development works complete by Q2 of that year. Further development milestones in 2023 show our solution ready for commercial rollout in Q2 or 3 of 2024. Our journey requires us to partner with suitable people to engage the solution in the market. We also confirm elements of our model and pricing at the same time. And as soon as our 200-unit trial is complete, with the major infrastructure works in place, we are ready for commercial deployment. Once the beachhead market is captured, we will develop further the InsurTech solutions and product further to reduce the capital cost to enable massive scale in this marketplace. We will also develop the value-added gold, silver, and bronze service delivery model. Canetia is committed to making our society safer, more efficient, and more sustainable by obtaining deep insights into building structural condition using AI. Our team offers deep experience in systems, civil engineering, and major infrastructure, and we have an established track record in some of the world's largest and most prestigious projects. We provide innovative solutions based on the fusion between established and emerging technologies such as ours. Let me introduce the team a little further. Dr. Nadia Shalabi is our COO and Innovation Advisory Partner. Dr. Shalabi is a highly successful technology entrepreneur, providing Canetia with visionary market positioning, establishment of resilient infrastructure, and excellent execution throughout all of our operations. Mr. Joe Allegro is our Chief Engineer and has 38 years' experience in the design and construction of major civil engineering projects, including those in rail, transit, highway, and in tunnels. He's a professional engineer registered in Massachusetts. He spent 20 years of his career in senior leadership positions for the Central Artery Tunnel Project, also known as the Big Dig in Boston. Joe is very interested in technological solutions as applied to older transportation infrastructure in order to make them more maintainable, reliable, and available. Aaron Tabella is our CMO and FinTech InsurTech expert with over 20 years' experience in product development, integration, and marketing expertise gained in FinTech and in InsurTech startups and within established players. Dr. Graham Sutherland is our Chief Systems Architect and CEO. He has over 25 years' experience in systems engineering, software design, and in product development. He's held senior leadership positions in some of the world's largest and most technologically challenging projects in transportation and in energy. He has also successfully delivered consistently proven technology innovations to these projects and in the market generally.